Hello everyone and welcome to the KWA Kriss Vector NPAS installation video. Now this guide will be as straightforward and as much to the point as I can make it. Now when you want this NPAS, then you will have to get onto the Heavy Recoil Club Discord group. Head over to the KWA Kriss Vector section, you can find me there. And if you want one, send me a direct message and then we can talk about getting you one. When you buy one of these of me, then I kind of hope that you know how to disassemble your Kriss Vector to get it in a fully disassembled state where you completely disassemble the nozzle and take out all the components. I still have the spring in here. Right. Yeah, because this is kind of what you will have. This bolt that we will be putting the NPAS in is from my KWA Kriss Vector, this one that I use the most. The other one, this one, is more of my collector's piece that hangs on my wall here. There are a few differences between my version that I play with and the wall hanger, because the wall hanger is still factory original. We've also taken that apart. You can see that this still has the original seal on the nozzle plug. This was the piston, was all still in good condition. Piston didn't break there, which is a point where it often fails. It also has the factory original spring. This one, apparently I've installed a different spring at some point. I wasn't really aware. So I'm also not entirely sure where this spring came from. It might be from the RA Tech NPAS, but I'm just not sure because it looks like that is the original spring when I look at the factory original parts. But we're going to leave this spring in as it is. Now these RA Tech NPASs, they of course don't work for several reasons that should be common knowledge by now. Else watch my KWA video. I explain a little bit about them in a bit more detail. I tried getting those to work also for the KWA Kriss Vector, but it didn't work, or at least I didn't test all that much with it because it didn't really yield satisfactory results after some modifications. Don't waste your money on them, it won't work. It's just that simple. You need to do a lot of modifications to try to get them to work. And for that you need a lathe and you need to know what you're doing. And it's just not worth the trouble. Just go with my option. This is something that works far better. On this version, I just took the prototype out and we're going to install the latest version, the version that will also be available. But I've already made some modifications to this specific setup. So here I have already removed the seal that's on the nozzle plug. Here I didn't, but we're going to do that. And then we're going to build everything together. The way I'm going to ship this out is as much drop-in ready as it can be, but there are still a few things that you need to check with great care so that it works, else you might experience some problems. You also get with a bunch of O-rings so that you can, for certain cases, tune the O-ring to your needs. For example, you will get 3 sizes of O-rings for the piston seal so that you can tune the outer diameter as close to the blowback housing or the bolt as possible so that you can create the most perfect seal without the piston dragging too much by the O-ring. Because if the O-ring drags too much inside, then it might not really cycle all that well because the spring will not be strong enough to pull it back, for example. Now you will also get 2 sizes of piston nozzle seal O-rings. When I ship these out, they will be installed with the thinner version, so that will be this one, 8 by 1 millimeters. But I also include a thicker version, 8 by 1.1 millimeters. With that you can tune how well this seals, because these parts are subjected to 3D printed tolerances that might vary from batch to batch, and with that different O-ring size, then you can tune it to what you want it to be or how you like it. Now on this version, I have installed the 1.1 by 8 millimeters O-ring, so the thicker one, and on this piston seal, it has the 12 by 2.5 millimeters O-ring, and O-rings are always measured by the internal diameter and the thickness of the cross section. It's also something that a lot of airsofters get wrong. Now, when these also ship out, it might be the case that you see a little bit of marks on them, or that they maybe show some signs of handling with dirty fingers. I cannot really do that much about that. Where I post-process these, so I post-process these by, among some other things that I post-process on these pistons, is that I machine the piston seal or the O-ring groove to spec. Now, where I do this, it's a dirty environment, and I cannot keep this really that clean. So in some cases, you might see that they have some marks, or maybe some dirty mark from dirty fingers, but that will not impair the function by any means. All right, but I will do my best to keep these parts as clean as possible. But when you see a little bit of dirt on them or some marks, just don't worry. I will also be shipping these out as drop-in ready as they can be, but still you do need to check a few things, and that is what we're going to show right now. So first of all, when you get it, you take it out of the packaging, then you can try and fit this. Now, with the smaller size O-ring, this should slide in relatively easy. You want to test this, that this can move freely just by holding these parts in your hand. That's really important. Then the next thing is that you're going to put this inside of the nozzle. I will also include a 1.3 millimeter hex key with the NPASs, but the hex keys will be black. They will not be shiny. And you can check if the adjustable valve moves freely. And right now I can look through the gas inlet of the nozzle, and I can verify that this now moves freely. That's really important, because the next thing, what we're going to do is we're going to assemble it. And after that, it still needs to do that. And it could be the case that something weird happens when you insert the pin, and that it then suddenly doesn't move all that freely anymore. So you do need to double check that. It's really important. Now you can use like an O-ring pick or something to pick up the spring. You can also attach a piece of fishing wire or something to the end of the spring to pull it up and then put it over the pin, just like that. Push it in and make sure that the spring is in the groove of the pin, And right now you want to check this again. And now in my case, now I feel a little bit of drag, and I don't like that. I don't want to feel that. And that is something weird that happens when you push in the spring. Now you can try and maybe bend that a little bit to see if that alleviates it. That seems to work. Don't overdo this, of course, because then you will break the NPAS, and without these fins on the piston, the adjustment will not work. It needs those fins for the adjustable valve to have something to constrain the rotation with. Now this feels good. That feels like it can move without friction. So one more time. Yeah, that should be good. Then we can take our spring, drop that in here, mate the adjustable valve with the spring, and the adjustable valve will come already with the set screw installed, and I will always leave it sticking out like a millimeter, maybe a little bit more, so that you're already in a certain adjustment region, and then you can adjust in or out to suit your needs. Then this should go together. Now, before we're going to proceed, I am going to put a little bit of silicone grease on that O-ring. I'm gonna just lightly lubricate the O-ring. So just like that. That slides in there really easy. And also for the O-ring on the piston, we also want to lubricate that. So you can remove it. Add a little bit of silicone grease all around. Don't have to overdo it. Just a little bit, like that. And then put it back on. All right. Now that's pretty much the installation process of the NPAS. Now you just put all the pins back in and put this back into the bolt, and then you're all good and you can test. Now this should move like this. If it doesn't move like that, if it moves with too much friction, then you might get cycling issues, because the spring needs to be able to push the nozzle with the new piston back with ease. That's important. Now let's push this out. For now, this all belongs together. Now we're going to work on this thing. So this thing is all, pretty much brand new. So what you can also see is that on the bolt, there's hardly any wear. So this thing hasn't been used that much. A few magazines I've put through my wall hanger, that's it. But when you take everything out, you of course have your spring. You have the pin, the rocket valve, and then the nozzle plug with the original spring as well. Now this thing, the rocket valve, you can put that to the side. You don't need that anymore. And we are going to modify this nozzle plug. And we're going to modify that with one of the O-rings that comes in the kit. And we're going to use the 3.3 millimeter by 2.5 millimeter O-ring. And it will be described on the package, and you can just measure it, which one is which. Because why are we modifying this? Eventually, this piece of rubber, just like on the KWA Tavor, this will wear out, it will degrade, and we need to make sure that the nozzle plug doesn't push the whole new nozzle assembly forward too much. Now this O-ring or this rubber that's on here, it's not on there for sealing, it's more to dampen the nozzle returning into its retracted position. It's not for sealing, but this hard rubber is too much, and it will likely cause the nozzle with the NPAS to be pushed forward a little bit too much. And so that's also why we need to do this modification. It's pretty easy. What we are going to do is, where's my knife? My knife should be here somewhere. We're going to make a gentle cut diagonally, and we're going to remove all this rubber from this nozzle plug. Now of course, be careful, don't cut yourself, and you will also experience how brittle this rubber actually is. You don't want to scratch the surfaces, that's important, because we don't want to create any unwanted roughness. And then when you've made a cut, then just switch to something that is less likely to cut yourself with, and just remove all of this rubber. Now, just pick up the pieces, throw them in the trash. So, and then verify that that diameter is clean, that all bits of that rubber have been removed. Maybe use a brush or something to brush the last pieces out, like that. And that's that. Now these edges, they can be really sharp. So what you might want to do is with like a polishing stone or a grinding stone, or a really fine file, or just some really fine sandpaper like 600 grit or something, just slightly polish those edges so that they're not that sharp anymore, because else there is a chance that it cuts into the O-ring when you're installing or removing it, and then you're already down one O-ring. But I will supply 2 O-rings of the 3.3 by 2.5 millimeter dimension, and 2 that are 3.6 by 2.4 millimeters in diameter, so that you can kind of mix and match to get this to work exactly as it should. And I will show that a little bit. I will show that in a minute after we've installed the O-ring. But first, just deburr this a little bit so that this isn't all that sharp anymore. And also the other edge. Now, there was an alternative way of making this NPAS, but then it would have involved machining a completely new nozzle plug and also supplying it with a new spring. And that was an expensive route to take, and of course that's why I didn't went for that option. So this is one of the only ways that this NPAS can work, but also that it is still affordable, because I have tried several options, but this was the one that was the easiest, and it works. So now those edges are lightly deburred. That's better. Now for the O-ring. This O-ring we can then slide over here, and this is the 3.3 millimeter O-ring in diameter and 2.5 millimeters in cross section, and tooth into place. Now, yeah, and this is already perfect. Yeah, really nice. So, what do we want? It's the same for with the KWA Kriss. We want it to stand off out of this. We want it to be in a resting position, just sticking out of the front surface of the piston, and when we apply a little bit of force, that it sinks just below the surface. And that is what we want to achieve, because then we get a little bit of dampening, and it doesn't push the piston and the whole nozzle too much forward in the bolt. And that's kind of what we want. And on this thing, that is the same, but here we already this was already modified. Just like that. The distance that the nozzle plug is allowed to stick out is about 3 to 4/10 of a millimeter, but when you apply just a little bit of force and you're able to push it below the surface, then it should be good. Now, when I ship these out, I will have modified this internal chamfer so that it's already drop-in ready. I will test this with the nozzle plugs that I have here, so that you don't have to worry about this, but that is something that I check individually for each NPAS that I ship out. But now this modification is done, and then we can grab an adjustable valve. This already has the set screw installed, it will stick out about a millimeter, maybe just a little bit more. And again, we're going to check if this can move freely. And that it can do. Now that fits really nice. And now let's see if it still moves freely. Yes, and we're not doing this with the spring installed, so that we are absolutely positively that it can move without any resistance. Can I try to push it back? Yeah. Now I can create a little bit of friction to pull the rocket valve back also when it is in its installed configuration, and it should spring back without getting stuck. Now this is a little bit tedious to do because you cannot grab under the rocket valve with like an O-ring pick or something. For a different nozzle design with the KWA Tavor that was possible, you can grab on the inside of here and then just push and pull it a little bit with also like a hook tool to verify that even in the installed configuration it can move without any resistance, also when the spring is installed, as a last final check. Now on this thing it works really good. And now we are going to install the nozzle plug. I'm going to take our pin and then we're going to use our hook tool. You can also use like a piece of fishing wire that I already explained to pull the spring eyelet up to make that maybe a little bit easier. And then maybe pull that back a little bit. Yeah. Yeah, like that, it's good. Oh, almost forgetting something. Now, also for this one, I think I'm going to go with the thicker O-ring. Now, your piston will come pre-installed with the thinner O-ring. It's up to you to decide which one you want to use or install. Just like that. And then this is the 12 by 2.5 millimeter O-ring that will also come pre-installed already. Oh, but when you get it, you do want to apply a little bit of grease, a little bit of silicone grease to it. Just like that. Now clean off my hands. Now you will also get some replacement O-rings for here on the end of the nozzle plug. So when that O-ring is damaged or whatever, you get two sizes so that you replace that if it needs to. I'm not entirely happy with how this fits. So what I am going to do is maybe with my file just rub a little bit of material off It's still not how I want it to be. And this is also something that you might need to do yourself. Installing the pin can cause these ends to bend in a little bit. So let's see what we can do about it. Now I'm going to leave that attached. I think that is... Yeah, now it can move freely again, so that's a little bit annoying. So what you can do is use a 7.5mm drill bit and some 240 grit sandpaper, just a tiny bit, to fold this around. Maybe you need to use a little bit of a longer piece. You can lightly sand the inside here so that it becomes a little bit more spacious for the rocket valve. And I hope you don't have to do this, but yeah, that's now much better. So this is also something that has to do with the 3D printing process. These surfaces are not injection molded smooth or anything like that. So it might be necessary to just lightly sand that surface a little bit. Now, before I ship these out, I will do this already for you once. But when you install this, you absolutely need to check if this runs without any resistance. That is absolutely vital for proper operation of the NPAS. I'm not sure if I explained that already, I don't think so. But there is one other thing that can cause the rocket valve to be pinched, and that has to do with the original nozzle. Now, these are also original nozzles, unmodified, original unmodified, and I think it's important to show you this. On the inside right there, you see that line, that bridge. That is an internal chamfer on the deepest pocket of the hole. Now that is also why these end passes have this ridge, that is to clear that chamfer. Now the prototype that I've been running for a while didn't have that. I noticed that later, and that caused the ends to be pushed in, and then I had to do a lot more sanding like this, like what I just showed. And also I had to cut away pieces here on the inside to widen it, so that under the deformed, so that when installed it would deform into a neutral position. Now that's of course something that is really annoying, and I noticed later, but that is something that these nozzles have, the original ones. There is a way to remove that. You can either use a modified reamer. I've tried that, but what you can also do is get yourself a 10mm drill bit and then just cut off the end. And with this, it is also possible to scrape away that small chamfer that is on the end of that internal pocket. But as it is, it should not be necessary to do that, and that's also what we are going to verify, or we already kind of did. So also a little bit of silicone oil or grease on the O-ring here. That will make installation a lot smoother and also keep the O-ring in good condition. And it is installed. And now I want to verify that this is moving absolutely freely, and it is. It's a little bit difficult to get it to stick. But that is absolutely important, that it returns without any hiccups. All right. that's pretty much how you install these. Off camera, I will assemble everything, and then I will do a shooting test with this one and also this one, so that we can compare the two small differences in between these two, because this one has a tiny bit stronger spring than the factory original one. Then we're going to see if there are any differences, because I don't think so. Yeah, here I also have two other different spare springs. One is for the Tavor, and the other one was also, I believe, from one of the RA-Tech valves, one of the RA-Tech NPAS valves. But I don't think it requires a stronger spring, but we'll see. So that's it. That's how you install one. If you think there is anything unclear, then use the comment section, or if you have any questions, get on the Heavy Recoil Discord group. Go to the KWA Kriss Vector section and start asking, or write me a direct message on Discord. You can find me on the Heavy Recoil Discord group under Spartan Airsoft Engineering, and then yeah, we can talk. If you want one as well, then get on Discord, write me a direct message, so that we can talk about getting you one. And right now I'm handling this through the Heavy Recoil Discord group, but I might partner with the Heavy Recoil Discord group and have it for sale on their store in the near future. It will depend. I have to talk to Bridges about that, but we'll see. The first batch is very limited. It's limited to 8 pieces. The next batch will depend on demand. So if you want one, get on the Discord group. Let me know if you want one, and then we can talk business in a direct message. We will continue this with a shooting test that is coming up next. I forgot one thing to mention. Now, I am not sure if my NPAS will fit in the black variable nozzle. Now, the only reference that I have are the original nozzles. I still have a few. I have not tested it with a black variable nozzle. Now, if you have a black variable nozzle, then you will have to experiment with that if it will fit or not. Now, if Black Variable has done a good job at making a good copy of this, copying all the features exactly, making sure that the dimensions are right, maybe he has excluded that stupid chamfer that's on the inside of the hole, then that's all fine. But if he's done a good job, then I don't expect that this won't fit. Now, if you do run into problems, please let me know, then I can see what I can figure out. Maybe make an adaptation or something, but the design has alone been based on the original nozzles. So if you do have a black variable nozzle, you will just have to see if it fits. If you do run into problems, just let me know. Before we get into the shooting test, I wanted to say a few more things. Now, I've already tested these, and I've seen that the spring stiffness from my tan Vector, which is slightly stronger than the stock black Vector, doesn't seem to matter that much. Now, if you want to experiment with a stronger spring for the rocket valve, for the adjustable rocket valve, then you can totally do that. I won't be experimenting any further with that. So, but if you do, if you, for example, use a rocket valve spring from like a Tavor or a LM4 or a different KWA platform, then please let me know how it behaves. If it is any different from what you will be seeing during the shooting test, then just let me know. Write me a message on Discord or post something in the comment section down below. Yeah, I'm curious. There will be a significant difference because I will not be testing any further. I'm happy with how it is as it is currently, and I'm just going to enjoy this. Now, the black Vector will be going back on my wall, but this thing I will definitely use more now because it's now much more usable. I've also already pre-selected 2 magazines. These magazines don't have a output difference, so we will be shooting about 20 rounds with the NPAS setting currently as it is. We will also be doing that for the black Vector. For the tan Vector, I will be turning the NPAS further up to get more output out of it, about 2 full turns to see what that does. And then for the black Vector, I will be turning the NPAS down about 2 turns, and then we can compare kind of what they are doing, because the adjustment range is a little bit more than that, but I think that will show enough. Currently they are putting out almost the same power. So then you kind of have an idea, if I turn it up 2 turns or turn it down 2 turns, then what the adjustment range will be. Now in the NPAS package you will get a bunch of O-rings, and of course the NPAS with a 1.3mm hex key, as long as I have some. 2 O-rings will already be installed on the NPAS. The package will say that it contains 2, but then 1 is already installed on the NPAS, so just so you know. And then without further ado, let's get into the shooting test. Shooting test with the 10 Vector. It's about 20 degrees Celsius in here, and we're using this ultra air orange gas. So that's 25 shots with the 10 Vector. Now I'm going to switch to the black Vector. All right, that's 25 shots with the black Vector, and now we're going to turn the black Vector down and the 10 Vector up. So first the 10 Vector. So this should produce now a little bit more output. So 2 rotations. So as you can see, pretty stable. So I was able to push a little bit more adjustment out of it. And I didn't regas the mag, so that's also important. Now let's switch over to the black Vector and see how that does. Now also for the black Vector, so this was adjusted further in to reduce the energy output. Magazine was not regassed. So as you can see, that has an effect. It is possible to turn the NPAS further in to reduce it even more. And it should still be possible to turn the 10 Vector also further out, so to get even more out of that. And we will show that in the next shooting test. Now for the 10 Vector, I've turned the NPAS all the way off. Well, actually in the previous test, when I turned the NPAS further in so that we get more output, it was already turned off. But I have now confirmed that, and this is with a regassed magazine, ASG orange gas. And I was running out of gas, so excellent preparations on my side again, but we'll see how this then does. So we have the 10 Vector again, this time regassed and refilled with BBs with Red Wolf green gas. Now the other magazine has been filled with ASG red gas. The NPAS is turned off on both the 10 Vector and the black Vector, so we will see what it does. Let's now switch magazines for the one with the different gas. Let's see. And let's now switch that over to the black Vector. So this is the black Vector. Also, NPAS is turned off. Switching magazines. All right, that's it. So, as you can see, it is possible to get about 1.4 joules out of this with 0.3 gram BBs. It depends on the temperature. Right now it is here 20 degrees Celsius, and it will also depend a little bit on, of course, the gas that you're using. But 1.4 right now with these conditions and these gases seems to be the maximum. And you can tune it down below 1 joule if you want, and if you want a little bit more oomph out of it, a little bit more power, then you can also use a black gas. Now let's do one more shooting test where I will be using some Nuprol 4.0 and see how that does. All right, so now we have the 10 Vector with Nuprol 4.0. So that was putting out 1.7 to 1.6. Now the black Vector, and this is again with the NPAS fully open. So on both rifles, NPAS fully open. And the black Vector is doing about 1.5 to 1.4. Now it totally depends on, of course, temperature and what gas you're using, but these are values that you can get. I hope this has been informative enough. So that concludes the KWA Kriss GBB NPAS project. The first batch is being put in boxes. I need to do the last fitment checks before I finish the packaging. First batch will ship out in these really nice boxes. Second batch will probably not, because I try to use as much repurposed packaging material as I can, because that also keeps the cost low for me and eventually also for you. I'm really happy with the result. So it is possible to get this thing tuned to about 1.2 joules. That is the range that I need to be in for this thing for here in the Netherlands. But it's also capable of pushing out just a little bit more. And you can also adjust it down to below 1 joule if that is something that you want to do. I'm really happy with this. It's now much more enjoyable. It's far more consistent than it was before. How it was stock, how it behaved previously all those years with the RA Tech NPAS that was in here before, that didn't work. So right now I'm just much more happy with this thing. Now I will make an additional video, it will come out later at some point, where I talk a little bit more about the modifications that I did to this thing, because I modified the hop-up. Now that modification will be something that not all of you can do, because you need a milling machine, but that is something for a future video. Now the first batch of NPASs will be limited to 8 kits. I will be making a second batch of NPASs, but that will depend on demand. So if you want this NPAS for yourself, for your own KWA Kriss, it only works for the KWA Kriss, then get on the Heavy Recoil Club Discord group. Find me in the KWA Kriss Vector section, and maybe send me a direct message. Then we can talk about getting you one. The second batch, because I think the first batch is pretty much already spoken for, but the second batch and if there is enough interest even after that, will be made according to demand. So I need to have a minimum demand for me to order parts, because I do need to place like a minimum order quantity for some of the components that are in the kit. And it also takes quite some time for me to post-process everything and make the packaging and everything like that. The second batch I will probably also be offering either through the Heavy Recoil Club Discord group website, or I will be offering it over at Airsoft Bazaar. It will depend. I haven't made up my mind about that, but that's something that I am considering. I am hoping that I can make a few of you happy with this modification, because it will make your Vector power adjustable and also much more enjoyable to play with. If you want one, read the description, and we will see you in the next video.